Hello, today I'm going to discuss the IB exam paper from May 2021 exam season. This is Chemistry Higher Level Paper 1. Question 1. Which contains the most atoms of oxygen? So oxygen molecule has 2 oxygen atoms. So first you find the number of mole, which is the mass 64 divided by the molar mass of oxygen gas, which is 32, times 2, because the number of mole of oxygen atom is twice the mole of oxygen molecule. And then times the Avogadro's number, which is 6 times 10 to the power of 23. B, this is already in the number of molecules of oxygen. So now the number of oxygen atom is just 2 times that number. C3H5O3, there are 3 oxygen atoms per molecule. So we find the mole first. 64 gram divided by the molar mass, which is 89. And then times that number by 3, because there are 3 times the number of oxygen atom, times the Avogadro's number. The last one is 1.2 times 10 to the power of 24 molecules times 3 oxygen atoms. So the most number of oxygen atom is D. Question 2. To find the empirical formula, we want to find the moles of C, H, and O. So 24 gram divided by the relative atomic mass of carbon, that gives us 2 mole. So now to find the simplest whole number ratio, divide everything by the smallest number. So you get 20, 30, and 1. Answer is A. Question 3. What volume of oxygen is needed when 5.8 gram of butane undergoes complete combustion? So we need to convert mass of butane to mole of butane first, and then use the molar ratio 2:13 to find the mole of oxygen. And then finally, we find the volume of oxygen at STP. So mole of butane is the mass of butane, 5.8 gram, divided by the molar mass of butane. So this is number 1. And number 2, the molar ratio between butane and oxygen is 2:13. So to find the mole of oxygen, mole of butane times 13/2, that's the mole of oxygen. Now, the volume of oxygen is just the mole of oxygen times the molar volume at STP condition, which is 22.7. So the answer is B. Question 4. The relative molecular mass of bromine. So this is talking about the bromine molecule because it's its molecular mass. Bromine isotopes are bromine 79 and bromine 81. Okay, when they form bromine molecule, there will be 3 peaks showing. This is bromine 158 and this one is 162 and the middle is 160. So the molecular mass of bromine is just the sum of the mass of bromine times its abundance. So in this case, 148 times 52 plus 160 times 100 plus 162 times 48 divided by the total abundance. All right, the answer is A. Question 5. A looks like an sp hybridized orbital. B is an s orbital. C a dumbbell shape. this is p orbital, and D looks like a pi bond, and pi bond is formed between two p orbitals that overlap sideways. So answer is C. Number 6. The diagram shows the first ionization energy of consecutive elements in the same period of the periodic table. Which factor explains why element X has a higher first ionization energy than element Y? Higher first ionization energy means it requires more energy to remove the first valence electron. Okay, let's take a look at the diagram. So I've written here the group number. We start with group number 1, 2, 13, and so on, or group 3. Let's use an example, magnesium and aluminium. Magnesium is in group 2, so that would be our X, magnesium, and aluminium will be our Y. When we remove an electron from magnesium for the first time, we will remove it from 3s orbital, one of these electrons. Whereas for aluminium, we remove it from 3p orbital, which is this electron. Now 3p orbital has higher energy, and it is experiencing more shielding by the 3s electrons. So therefore, it is easier to remove this electron on the aluminium. And that's why the aluminium first ionization energy is lower than that of magnesium. Now, there is also a discrepancy here with element from group 15 and 16. Let's take a look at another example. We'll use phosphorus and sulfur. The electron configuration of phosphorus is written there. And if we draw the 3p orbital, we will get something like this. And so when we remove one electron from S, we are actually removing this electron, because this electron is the one that is easiest to remove, as it is experiencing some repulsion from this other electron. And therefore, it requires lower energy to remove this electron. And that's why the first ionization energy of S is lower than that of phosphorus. So the answer is A. Question 7. Which species has the same electron configuration as argon? Argon is here. And we have bromide, meaning bromine gain 1 electron. That would have the same electron configuration as krypton. Whereas calcium losing 2 electrons, so you go back 2 times, 1 and then 2. Calcium is nearest to the noble gas of argon, so calcium ion has the same electron configuration as argon. Because all these elements, they want to be stable, they want to have the same electron configuration as their nearest noble gas. Aluminium will have the same electron configuration as neon. Silicon will have the same electron configuration as neon as well. Answer is B. Question 8. Which trend is correct going down group 1? Group 1 is metal. As we go down the group, the radius increases. So let's take a look at sodium and potassium. Sodium is above potassium. Because the valence electron of potassium is farther from the nucleus, so this valence electron is held more loosely and it's easier to remove. So potassium is more reactive than sodium. Remember, metals, they react by losing electron, not gaining. So we can also say that the first ionization energy is lower. So C is incorrect. Reactivity, B is also incorrect. Now, electronegativity has to do with how strong an atom pull electron towards itself. So because potassium has a large ionic radius, when there is a nearby electron, it has weaker pull, or you can say it has weaker electronegativity. So D is correct. Now, melting point of metal. In metallic bonding, positive metal ions are surrounded by the sea of electron, and there is a strong electrostatic force between the cation and the electrons. Now imagine we have a larger cation attracted to the sea of electron. Actually, it's the nucleus of the cation that is attracted to these electrons, right? Because nuclei are positively charged and the electrons are negatively charged. So if the ionic radius is larger, there is more distance between the nucleus and the sea of electron, and the attraction is now weaker. But for smaller cations, the distance between the nuclei to the delocalized electron is close. So the electrostatic force is stronger. So as we go down the group, the melting point decreases. Answer is D. Chromium 3 complex. So the charge on chromium is 3 plus because it's chromium 3. Water is a neutral ligand, so the charge is 0, whereas chloride is -1 for each. So we have a total of 2 chloride there, and total charge is +1. Question 10. So I've drawn here the structure of each of these compounds. Magnesium oxide is just ionic. Dichloromethane is covalent. Ethanoic acid is covalent, but sodium hydroxide has both ionic and covalent bonds. Ionic between sodium and hydroxide ions, and the covalent bonds between O and H. Question 11. Ionic compounds usually have high melting point because they have very strong electrostatic force, and they are soluble in water but insoluble in organic solvents. And electrical conductivity is low for solid state because the ions are not freely moving. Answer is D. Right, question 12. Which contain delocalized electrons? So if there is a resonance structure, that means there is delocalized electrons. In benzene ring, it's very clear. It has delocalized electrons. In ethanoid ion, let's take a look at this structure. If the lone pair of electron on this oxygen pushes and forms double bond there, this double bond will break and form a negative charge on the upper oxygen, and you will get the second possible structure, and this is the resonance of ethanoid ion. Whereas carbonate ion, this lone pair of electron pushes here, establishing a new double bond. And then this lone pair can also push there, and this double bond breaks. So all 1, 2, 3 have delocalized electrons. Answer is D. In which series are carbon atoms sp2 hybridized? sp2 hybridized happens when carbon has one double bond. I've drawn all the different structures here. Let's assign the hybridization. Let's take a look at ethine for an example. The electrons in the first energy shell of carbon will not be involved in bonding because it's not the valence electrons. Now the valence electrons are in energy level 2, and one of the electrons have been excited to the 2p orbital, right? Forming 4 orbitals with single electrons each so that carbon can form 4 covalent bonds in total. But to form triple bond like this carbon needs to reserve 2p orbitals to form the 2 pi bonds. What does it mean? It means that these 2p orbitals, they will not hybridize. Whereas these 2 orbitals, they will hybridize. So because you have one s and one p hybridized orbital, it's called the sp hybridization. So this carbon here is sp hybridized. Sp hybridized. The second compound there is methanol, and this carbon is sp2 hybridized because one of the p is reserved to make one pi bond. Methanoic acid is also sp2 hybridized on the carbon. Carbon monoxide is sp hybridized, as well as the carbon on cyanide. Ethane is sp3 hybridized because it doesn't form any pi bond, so it doesn't need to reserve any p orbital. Same for methanol, sp3, and so the answer is B. Question 14. We're given the mass of water, change of temperature, and the specific heat capacity. To calculate the enthalpy change in joule, let's first convert the unit of specific heat capacity to joule per gram per Kelvin. Now, mass of water is 5 gram. The change of temperature is just 18 minus 10, which is 8 Kelvin. If we convert the temperatures to Kelvin first, we will still get 8 Kelvin. And delta H is mc delta T. Cancel whatever unit you can cancel. So now we are left with the unit of joule, which is what they want. And the answer is A. Question 15. We're going to use these enthalpy change of combustion values to find the enthalpy change of the reaction given up here. Change of enthalpy of combustion shows how much energy is generated when the substance is combusted. So for example, graphite, carbon, when combusted or reacted with oxygen will give you carbon dioxide and 394 kilojoule of energy per mole. So I have written down here the equation for the combustion reactions of these two substances. Now we have 2 moles of carbon giving 2 moles of carbon monoxide. Here we have only 1 mole of carbon and 1 mole of carbon monoxide. So first what we want to do is multiply both equations by 2 to get the correct coefficients. And then we want to reverse the second reaction because carbon monoxide is going to be our product. So when we reverse the equation, we also have to reverse the enthalpy sign. Okay, now we're going to cancel the carbon dioxide and oxygen, and we get our equation as written above here. Now the enthalpy change is just the sum of these numbers. So the answer is D. Question 16. This data shows that as temperature increases, the value of Gibbs free energy becomes more negative. That means the reaction becomes more spontaneous. So the more negative Gibbs free energy, the more spontaneous a reaction is. To get a highly negative value of Gibbs free energy, the product of temperature and the change of entropy must be increased. So that means as temperature increases, the delta S also increases. And this shows us that entropy is higher in the product. Answer is C. Question 17. Lattice enthalpy depends on two factors, which are the ionic charge and the ionic radii. So the higher the charge, the higher the lattice enthalpy, and the higher the radius, the lower the lattice enthalpy. So we can combine these two factors and think of them as charge density. The higher the charge density, the higher the lattice enthalpy. KCl and Kf, they have low ionic charges because +1 and -1. But calcium, they have a +2 ionic charge. Chlorine is larger radius than fluorine. So calcium fluoride actually has the highest lattice enthalpy. Question 18. We react marble chips with excess hydrochloric acid, and the following curve of mass over time is obtained. This loss of mass is due to the mass of carbon dioxide that is produced. So curve 2 shows that the initial mass of beaker is higher than curve 1. That means that there is more mass of reagents. And the slope is steeper for curve 2. That means curve 2 must have higher rate of reaction. Now overall, the loss of mass in curve 1 is this much. But the loss of mass in curve 2 is this much. That means approximately twice the volume of CO2 is produced in the second experiment. To get higher rate, we can have powdered marble chips, and to get twice the volume of carbon dioxide, we need to double the mole of the limiting reagent, which in this case is marble chip. Double the mass of marble chip, the answer is B. Question 19. The area C it shows the number of particles that can collide with enough kinetic energy to overcome the activation energy. And the activation energy is B. Question 20. So in this reaction, there are two steps and we're given the mechanism. I have copied down here for extra working. Which rate equation is consistent with this mechanism? So we can have two options here. Step 1 is the slow reaction or the rate determining step, or step 2 as our rate determining step. B is our intermediate, so they are not involved in the final reaction equation. In the first scenario, the rate equation would be rate constant times concentration of A times concentration of A, or simply K concentration of A square, because only species involved in the rate determining step will be included in the rate equation. Now, for the second scenario, the rate determining step is step 2, but step 2 involves B, which is our intermediate formed in step 1. So, the rate of step 2 actually depends on how fast step 1 reacts. So, in that case, these two species will be included in the rate equation because the rate of step 2 depends on the formation of the intermediate in step 1. Okay, so Now, there is only one possible answer here, is C, because the second scenario is not one of the options. Question 21. Which graph shows a first order reaction? So first order reaction is when concentration doubles, the rate doubles, or the time halves. But when the concentration is halved, the rate also halved, or time doubles. Okay, so take a look at V. When concentration is here, time is here. And then we halve the concentration. So now we are here. And time taken doubles. So this is halving the concentration doubles the time. That is first order reaction. Now, let's take a look. X is zero order of reaction because the rate does not depend on the concentration of the reagents. I look at Y. When we have, let's say, concentration here, we have this rate of reaction. And if we double the concentration, we will double the rate, right? So this is also first order reaction. Answer is V and Y. Question 22. Which changes produce the greatest increase in the percentage of conversion of methane? So remember Le Chatelier's principle. Now on the left hand side of the equation, we have a total of 2 mole of gas, and on the right we have a total of 4 mole of gas. If we want to drive the equilibrium to the right, encouraging conversion of methane, we want to lower the pressure because higher mole of gas is favored by lower pressure. Now, we want to drive the equilibrium to the right. So we have to increase either methane or steam. So answer is C. We can also drive the reaction to the right if we eliminate the products. Question 23. 1 mole of each sulfur dioxide, oxygen, and sulfur trioxide are in equilibrium. Which change in the molar ratio of reactant will cause the greatest increase in the amount of sulfur trioxide? The molar ratio between sulfur dioxide and oxygen is 2:1. Given this number of moles, we know that sulfur dioxide is the limiting reagent. So it is used up by 0.8, which means it will require 0.4 mole of oxygen. Sulfur dioxide is the limiting reagent. It is always used up, so it's used up by 0.8. Now the molar ratio is 2:1. So 0.8 mole of sulfur dioxide requires 0.4 mole of oxygen. Now let's do the calculation for each of these rows. So from here we can see that the last row actually gives us the least excess reagent, and therefore we have a maximum product formed. So answer is D. Question 24. Which is amphiprodate? So amphiprodate means the species can accept or donate hydrogen ion. I have copied another set here. So this side is for showing you that the species can actually accept hydrogen ion, and on this other side is to show that it can donate hydrogen ion. Ammonium ion cannot accept another hydrogen ion because it has already accepted one. Hydronium ion also cannot accept another hydrogen ion. And phosphate ion doesn't have hydrogen ion to donate. So the answer is C. Water can accept and donate hydrogen ion. Question 25. pH 9 is alkaline, so it cannot be A or D. pH is negative log hydrogen ion concentration. But because we're dealing with an alkali, it doesn't have hydrogen ion, but it has hydroxide ion. So we're going to convert pH to POH. POH is just 14 minus pH, so it gives us 5. To calculate POH, we can also use negative log concentration of OH minus. So in option B, we have negative log 10 to the power of negative 5, and that gives us 5. Whereas C, negative log 10 to the power of negative 9, and that gives 9. B is therefore our answer because POH 5 is just the same as pH 9. Question 26. Which is a Lewis acid, which is electron pair acceptor, but not a Bronsted-Lowry acid, which is a proton donor? I've included all the images here. Let's take a look at boron trifluoride. Boron only has 6 valence electrons around it, so it can actually accept another pair of electron from a base. It is not a Bronsted-Lowry acid because it doesn't have proton or H plus ion, so the answer is A. But let's take a look at hydronium ion. Oxygen already has 8 electrons around it, so it cannot accept any more electron pair. Ammonia is not an acid, it's actually an electron pair donor, so it is alkaline. Chloride is the conjugate base of hydrochloric acid, so it is also not acidic. Question 27. Which combination will produce an alkaline buffer in water? What makes an alkaline buffer is a mixture of a weak base and its salt. So looking at the option, we can already eliminate C and D because sodium hydroxide is not a weak base. Right, let's take a look at A and B. Let's write down the moles, and because these two react in 2:1 ratio, so they react just in the right amount. So at the end, we have no more of the acid and base, but we have 0.05 mole of salt. How about B? B here, we're provided with 0.5 mole of ammonia and 0.1 mole of sulfuric acid. So to tell quickly which one is the limiting reagent, you can do this. Take the mole, divide by the coefficient. Take the mole, divide by the coefficient, and compare the number. The one that gives you the smallest number belongs to the limiting reagent. So in this case, our limiting reagent is sulfuric acid. Because it's limiting reagent, so all of it is used up. So 0.1 sulfuric acid requires 0.2 ammonia because the molar ratio is 2:1. And you produce 0.1 mole of ammonium sulfate because the molar ratio between sulfuric acid and ammonium sulfate is 1:1, right? So at the end, we have a mixture of weak base and its salt. So this is a buffer solution. Answer is B. Question 28. Which of the 4 metals is most reactive? Now look at Z ion. W and X cannot displace Z. So Z must be very reactive. So the answer is D. But let's put all the metals in order. Look at metal W. It cannot displace any of the other ions. That means W is the least reactive. Now between X and Y, X can displace W and X can also displace Y. So X is more reactive than Y. Question 29. Assign the oxidation number first. Manganese is getting reduced here and iodide is getting oxidized. So A is the answer. A reducing agent is a species that gets oxidized because it reduces others. So that's iodide. Question 30. Which gives the equation and cell potential of the spontaneous reaction? This is the principle of galvanic cell. So if you're given the standard electrode potential, the value that is more positive is the one that will undergo reduction. So we do not need to reverse the second reaction, but we do need to reverse the first reaction because we cannot have two reduction, right? One must be reduction and the other one is oxidation. Our oxidation is going to be the first reaction. When we reverse the equation, we also reverse the sign of the electrode potential. So when we add them up together, we get D. Spontaneous reaction must have cell potential of positive value. And we can see that the total here is positive. Question 31. What are the products when concentrated copper 2 chloride is electrolyzed using inert electrode? We list down all the ions first. We have copper 2 chloride, hydrogen, and hydroxide ions from water. Copper 2 can potentially give us copper as a product, and hydrogen ion potentially gives us hydrogen gas. So we compare the reactivity of the two products. The one that is more stable or less reactive is the one that's going to be produced. So in this case, copper is going to be produced on the cathode. This is our negative electrode, so it's called the cathode. And the half equation here is copper 2 plus 2 electron is reduced to copper solid. And on the other side, which is our anode, because we're dealing with concentrated halide solution, so it's the halide that's going to be discharged. And the equation is, answer is C. Question 32. Which series is in order of increasing boiling point? That means from low to high. So I've highlighted all the molecules that can form hydrogen bonding with water or with each other. They must have the highest boiling point. So B is the answer. Now take a look at the other two compounds. Propanone is a polar compound. So it experiences dipole-dipole intermolecular force. Whereas propane is nonpolar. So it is experiencing a weaker version of intermolecular force, which is the London dispersion. Question 33. Naming this compound, we have to find the longest main chain first. So it consists of the functional group, and overall it has 6 carbons on the chain. So this methyl group is going to be our branch, right? So now methyl is on carbon number 4. So we write 4-methyl. And the main chain consists of 6 carbons, that's hex, and it's a double bond on carbon 2 and 3. So hex 2 in. Remember, we choose the smallest number. Answer is A. Question 34. What is formed in a propagation step of the substitution reaction between bromine and ethane? So this is free radical substitution. In the initiation step, bromine is undergoing homolytic fission in the presence of UV light to give 2 free radicals. And in the propagation step is when a molecule reacts with a radical to give another molecule and another radical. Whereas termination is when two radicals react with each other, forming a non-radical. So here the answer is A. Question 35. Which is most likely to hydrolyze via an SN1 mechanism? SN1 mechanism is unimolecular, which means that the rate determining step or the slow rate involves only one molecule. And let's assign the degree of the halogenoalkane. A is a secondary halogenoalkane, B secondary, C is a tertiary, and D is a primary halogenoalkane. The higher the degree, for example, tertiary halogenoalkane, will form a more stable carbocation when bromine C forms the most stable carbocation, so it is most likely to hydrolyze via SN1 mechanism. Answer is C. Once carbocation is formed, then the hydroxide ion from sodium hydroxide or potassium hydroxide can now act as a nucleophile and attack this positively charged carbon, forming an alcohol. Question 36. What is the product of the reaction of benzene with a mixture of concentrated nitric and sulfuric acid? The reaction of nitric and sulfuric acid will give you nitronium ion, and it acts as an electrophile, which means the delocalized electron in benzene will attack the ion and from this species. And then the lone pair of oxygen of water will attack this hydrogen, and the carbon-hydrogen bond breaks off to re-establish the delocalization of electron on benzene ring. Answer is C. Question 37. Chiral centers mean carbons that are bonded to 4 different substituents. So there are 4 here. Answer is C. Question 38. The enthalpy of combustion of a fuel was determined using calorimeter. The final result was lower than the literature review. If the final result is lower, that means that the temperature change that is measured is too low. Okay, statement 1. Not all heat from the combustion was transferred to the calorimeter, and this could cause the temperature change to be too low. So it's correct. Incomplete combustion occurs. This also will reduce the energy that is given out, so the temperature change is not as high as it should be. So it's correct. The temperature probe touched the bottom of the calorimeter. Now, if this probe touches the bottom here, this bottom part is hotter than the water because it is closer to the burner. So instead of getting a temperature change that's too low, this should give a temperature change that is too high. So 3 is not the factor. Answer is A. Question 39. Burette reading is accurate to 0.05 cm cube. Okay, so I have calculated the volume of the solution used. And because the volume used is just final minus initial, we need to find the uncertainty by adding up the uncertainty of the final with the uncertainty of the initial reading, which will give us 0.1. So the mean titer is 11.15, which is the average of all these, plus minus 0.1. So answer here is D, rounded to 3 sig figs. Question 40. Which compound produces the following proton NMR? So we have two signals, multiple splitting. The splitting just tells us that there are multiple neighboring hydrogens. Two signals tells us that this compound has two different hydrogen environments. And the peaks both occur at lower chemical shift, which means they are quite shielded. They indicate they are most likely alkyl group that are away from electronegative atoms. Propane has two different hydrogen environments. This is one, and this is another one. So it will show two peaks. Propanone has only one hydrogen environment because the methyl group on the left and on the right are exactly the same. C has three different hydrogen environment, 1, 2, and 3. Whereas D, all these methyl groups are completely identical, so it will show one peak only. So the answer is A. Thank you guys for watching. If you find the video useful, please like and subscribe.